So in this class, let us discuss about flip-flops. A flip-flop known as a bistable multivibrator has two stable states. It can remain in either of the states indefinitely. Okay, na? So flip-flop nothing but it has two states, Q and Qn bar. If Qn is 0, Qn bar will become 1. So it is an example of a bistable multivibrator. Bistable means two two states. Q is one, S is one state and R is another. Set and reset state. Outputs are Q and Q bar. If Q equals 0, Q bar equal to 1. So this flip-flop always remains in the same state until you give the next input. Okay, now if you are giving next input, it is going to change into the next state. If you are not giving any input, the flip-flop remains in the same state. Okay, now that is nothing but it can remain in either of the states indefinitely. Same state it will be there until unless you will give them next input. Okay, now we are going to talk about SR flip-flop. I'm going to discuss about SR flip-flop. Okay, S means set, R means reset, and here already we have discussed SR latch. SR latch. Latch means no clock is given. SR flip-flop means it is a clock enabled. Only extra term will come is a clock enabled. So in latch there is no clock. Okay, now right. So this is a logical symbol of SR flip-flop, and this is a truth table of SR flip-flop, and this is a diagram of SR flip-flop. Okay, now block diagram of SR flip-flop. Okay, now so SR flip-flop nothing but see this here. It is SR latch only. Here to here it is just simple SR latch. Just now already in the previous class we discussed. It is SR latch. So SR flip-flop equal to SR SR latch plus a clock plus SR latch, nothing but a SR flip-flop. So it is a SR latch, and here to here it is simply it is a clock enable. Okay, na clock plus SR latch is give us a SR flip-flop. Okay, na right. Now I'm going to discuss about this. Okay, so truth table is everything is same as the latch only, but extra clock is given. Okay, na right. So first I will draw again for understanding. This is a SR flip-flop. So SR latch. I'm going to draw first SR latch. So this output is given to input of this. This output is given to input of this. So this is Qn and it is a Qn bar, right? So it is a SR latch. Already this is SR latch simple, but we are providing a clock enable now. So this is a clock I am giving here. This is a clock. So in order to provide the clock, I am giving like this. So this is nothing but a clock. It is nothing but a clock. So this part is nothing but a clock, and this part is this is SR latch here, and it is the just clock. This is nothing but a SR flip-flop. Same thing I wrote here. Okay, simple. So if you are for SR latch, if you are providing extra a clock to the SR latch, so SR latch will become a SR flip-flop. Okay, right. Okay, now you will go to the truth table. So this is a truth table of SR flip-flop, right. Okay, now some extra clock. C means clock will be provided. This is the extra clock. This indicates clock is high. Okay, na? So this indicates clock is always high. So similarly, as you know that SR flip-flop, so S and R are the present inputs. Qn is the past output. Qn plus 1 is the next state output. Already I discussed this truth table in the previous videos. Just go through that and understand that. Directly I am explaining here. Okay, now these two are present inputs. So this is a past output. So when we are giving present inputs and past outputs, so this is a present input, S and R are the present inputs, and this is a Qn bar and past. So after giving present inputs and past outputs, it will produce a next state output Qn plus 1 bar. Okay, now output is always complemented with each other. Okay, next. Right. Now because of, as you know, there are three variables are here, S and R are the present inputs. Qn is the previous output. No, so how many three variables are there? So that's why 8 combinations: 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Okay, now so okay, next in order to the next state. Okay, this is the next state. So already a detailed truth table I explained in the previous video. Same concept will be applicable here. And so I'm going to talk about simple SR flip flop. Okay, now you should remember N R S I. Okay, so you should remember the truth table in this form. So N means no change, R means reset, S means set, I means invalid. So this SR flip flop truth table is same as the SR latch using NOR gate. If you want, you can go back to the video and watch it. So it is also NRSI. Okay, so SR latch truth table is exactly same as the SR latch using NOR. Okay, right. So now I'm going to explain what is NRSI. So just remember, right? N means no change. N means no change means the present output is same as the previous output. Present output is same as the previous output. So Qn is the previous output, no? And Qn plus 1 is the next state or present output. Present output is same as the previous output. Okay, no reset means just reset means 0 0. So now, so independent of the previous or past output, my next state is I'm going to always get independent of the previous states. I'm going to get my next state is what? 0 0. I don't independent of previous output. Next is set state. Set means 1 1. Set means remember 1 1. Independent of the previous states or past outputs, I'm going to get 1 1 as my output. So independent of the previous states and past state 0 or 1, I'm going to get don't carry conditional. It may we cannot find it undetermined. Okay, that's why it is called as a indeterminate. Okay, so SR flip flop should remember what is the truth table here? NRSI. SR latch using NOR gate, NRSI, both are same. Okay, SR flip flop, NRSI, SR latch flip flop means clock enabled, only extra clock will be added. But truth table of SR flip flop and SR latch using NOR both are same. And already in the previous video I explained about SR latch using NAND gate. SR latch using NAND gate means this truth table will be reverse. N R S I know. It will be reverse. I S R N. I already explained in the previous video. Just go back. Okay, here if it is a SR latch using NAND means, okay, here I will come here. Okay, so we will get confused. So I don't mention here, but you remember that. Okay, so SR latch using NAND is reverse. SR flip flop and SR latch using NOR both are same. Okay, so this is a block diagram of a SR flip flop. Okay, and it is a truth table I discussed, and it is a logic symbol of the SR flip flop. Okay, right. So thank you very much. Thanks for watching.